Okay, so today we are going to do the Speed of Sound Lab, and we are going to use resonance to figure out what the speed of sound is with our basic formula: velocity equals frequency times wavelength. And with resonance, we have a few tricks. Well, first let me talk about what equipment we have. So here I just have laid out some different tuning forks that go from 329 hertz to 480 hertz. And this is going to be, so this is our source. So we know, so this is the frequency we're going to have. We're going to set up. Then I have a meter stick here set up so that we can record a height of our tube. And our tube, this is our instrument here. This is just a piece of PVC pipe that's open at both ends. But we are going to be placing it in water here. And when we do that, we effectively make this a closed tube pipe resonator. So we're going to have one end that the water level, and it's adjustable. That's the great part. So we're going to be moving this up and down, and we will be able to adjust the length of this pipe. What we learned in our notes was that if I tap a tuning fork and set up a vibration up here, then when I do that, okay, then this vibration is going to make a wide or high amplitude right here. And if I have this adjusted just right, that this is sending, right, the certain frequency, it will be just right that it comes down and comes back up like this. And so what we get is maximum amplitude to a node. Now, so maximum amplitude to a node is 1/4 of a wave, and then it reflects back. So we will know when we have this set up just right that we have 1/4 of a wave, standing a wave, as our shortest distance right here will be 1/4 of the wave. So we'll know the wavelength, and then we will know the frequency, and with that we will know what the speed of sound must have been. Let's do some first stuff that we need. We need the temperature. So I have water here that I added some ice so it was nice and chilly, because we're going to be doing part A and part B. And part A, we are doing it at a colder temperature than part B. So I'm going to turn on my thermometer here, and we are going to be putting it in here and seeing. So, you know, air temperature, water temperature, we're hoping those are kind of the same here. So I have a temperature of 14.9 degrees, okay, Celsius. Okay, all right, so I have the temperature now, and I'm gonna set up a here is our first tuning fork. Can you read that number? If you cannot read it, it's 329.8. Okay, so I'm gonna move the camera up so you can see what I'm doing here, and then I will get a close up so that you can actually read the numbers. So I'm gonna start with this tube a little bit long, and then I'm gonna set this up, and I'm gonna lower this until I can hear the sweet spot. All right, can you hear that? And then I'm going to adjust it. I'm going to bring you in. Maybe that's a little too far. Okay. All right, let me do this again. Can you hear that? I'm trying to find that loudest point. All right, I think it's about there. Okay, now you have to read. So I have to drop this a little so you can see the bottom of the tube number. Okay, can you see the water level is right here? So you need to read the height of the bottom of the water level. Okay, so it's about right there. okay? And then you need to measure the height of the top of the tube, okay? Okay, so when you subtract those two numbers, you will have the length of the tube that is exposed. So the closed tube resonator of this length, and we have the frequency, okay? And now we just repeat this. Okay, sorry, I keep having to adjust this a little bit so you can see a bit better. Okay, so that was at 329. The temperature is just one temperature reading for part A. Okay. So let's see what we're gonna get. Oh, I'm sorry. So now we have our next tuning fork right here. Ooh. Okay, so that is 392 and it says G. Okay. I'm going to bring you in again. Now, don't assume that the bottom water level is going to be numbers always the same, because as I move that tube in and out, it displaces the water, right? So we do have to be careful about that. Oops, sorry. Okay, so read the height of the bottom water level. You can hopefully see that about right there. Okay, and then the top of the tube. And don't forget later to change your centimeters into meters. Okay, so we'll move on. Now, the next tuning fork, it is 426.7, an A. Okay, lift this out a bit again. I think that's good. Oh yeah, that's nice. Okay. It's like a pipe organ, right? Okay. Again, read the bottom of that water level. Here, let me drop you a little bit. Okay. You can see that water level. And top. Okay, and now our fourth, and I guess last, I might do an extra. I have right here, oh, it's really hard to read, 440, and it says an A. Just make sure. Okay. All right, it's the bottom. On top. Okay, and then I'll do an extra one if you're interested in getting another number, or if you think one of the numbers didn't look so good, it didn't seem to be as constant later on, then you have an extra reference, which is always nice. Okay, so let me do that one. Oh, I'm sorry, it's 480. See that? Okay. Oh, that's nice. All right. Okay. All right. So now we are just going to repeat this process, but we're going to do this with some hot water. Okay, so that we're trying to see if we can see a difference between the speed of sound with cold and hot water. So cold and hot air, because we're hopefully that the water is going to be creating, right, let me let the water run a bit. So that we're assuming that if I have hot water, that the air in the tube above the hot water is also getting warmer, okay? So let's see if we can do that. All right, so now we have some hot water. So we are, for trial 2, or part B, we are going to stick my tube in here and then wait for the air temperature in the tube to increase a bit. Turn on my thermometer and let's see. Okay, it's starting to go up a little bit here. It's really cold in this room this morning. I don't know. It's not so appreciably warmer. So, a little bit. I got 19.2. All right, let me write that down. Okay. All right, so we are just going to run through this again. So I'll do in the same order. The 329 is going to go first. This is a really crazy lab to do with a full class of students doing this, because all of these start resonating, and then you can't hear if it's your tube or someone else's tube that is making noise. So it's a bit of a comedy in class. Okay, so again, trying to make sure you can see that the lower water level right there. Okay, compare that. Okay, and then I'll move this up and you can see the height again. All right. We might not have enough temperature difference to get an appreciable difference for the two trials, but otherwise we just have 2 trials, I guess. All right. We are now again going to do the 392. Okay. All right. All right, now the 426. That one's nice and loud. Okay. All right. Now the 440, the A. Okay. And then the spare, again, you can determine what is the best reading out of the 4 if you want, or use all 5 pieces of data. Those higher frequencies are definitely louder. Okay. All right. So now it is time to do calculations. You are going to now complete the data table on the back. You're going to transfer some information, and then you have to see the formula for doing corrected tube length So there's a little discussion about that. And then you're going to find out your experimental velocity. Because we haven't done that yet this year, we're going to analyze our data a little bit. You're going to find the mean, and then you are going to calculate the standard deviation. So I have a formula for standard deviation. Hopefully you've done that in another class. If not, you can probably easily find a little YouTube video on doing that. But it should be pretty straightforward with that. Okay, and then there's some little questions at the end, and you should be all set. All right, so good luck.